In this action review, we're going to talk about independent and dependent events, and we're going to do 1 and 2 together, and you will do 3 and 4 on your own. If we take a look at number 1, we want to determine if the following scenarios consist of independent or dependent events. We want to justify our answer. So we look at A. It says there are 8 red M&Ms, 6 green M&Ms, and 4 blue M&Ms in a bowl. You pick a red one from the bowl, eat it, and then you pick a green one. The key thing here is that you removed an M&M and you ate it, meaning you did not put that M&M back in the bowl. Because you did not put the M&M back in the bowl, that changes the amount of M&Ms, which changes the probability. When the probability changes, the events are dependent. And that would be your explanation. Okay. Did not put M&M back in the bowl. So that changes probability. The probability changed. Just some sort of explanation along those lines about not putting the M&M back, ate the M&M, so the probability changed. That would be an example of a dependent event. For B, it says you flip a coin and it lands on heads, then you spin a spinner and it lands on 2. To think about is the first thing affecting the second thing. So is flipping the coin affecting what the spinner lands on? And the answer is no. One has nothing to do with the other. So that would make it independent. Because the coin is not affect a survey was done at number 2, and then they found that 42% of the people watched scary movies and 16% suffered from nightmares. If 32% of the people watched scary movies and had nightmares, is having nightmares dependent on watching scary movies? Whenever you're given this type of question, you have a bunch of percentages, and you're asked if something is independent or dependent. This is where you're going to use the product test. Okay? That's where you multiply the two probabilities together. So we're going to multiply the probability of scary movies times the probability of nightmares. I'm abbreviating. And if they're independent, that should equal the probability of both scary movies and nightmares. Okay. So if you notice, everything's a percentage, so you have to change it to a decimal in order for it to be a probability. So 42% as a decimal is 0.42. So that's representing the probability of scary movies times the probability of nightmares, which is 0.16. If they're independent, that should equal the probability of both, which is 32%. So that's 0.32. So you plug that one side in your calculator, you're going to do 0.42 times 0.16, and you will get this. And that does not equal 0.32. So, yes, there is dependence. If you watch scary movies, more than likely you're going to be having nightmares. There is dependence. Go ahead and try 3 and 4 on your own. They're very similar to 1 and 2. When you are done, make sure you check your answer with the key to make sure you did everything correctly. And if you need to, feel free to watch this again.